You are watching AliAziz Quality Education YouTube channel.
Digital Techniques / Electronic Instrument Systems in BSc Aircraft Maintenance Engineering Technology, AMET, by AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry related videos, so don't forget the subscription button.
Modern aircraft are highly dependent on digital systems and electronic instruments for navigation, communication, flight control, and monitoring. The subject Digital Techniques / Electronic Instrument Systems introduces students to the principles of digital electronics, logic systems, microprocessors, avionics data buses, and cockpit instrumentation. This course enables AMET students to understand how digital techniques are applied in aviation and how engineers maintain, troubleshoot, and ensure the reliability of electronic instrument systems. Objectives of studying aviation digital techniques / electronic instrument systems. To provide knowledge of digital electronics and logic circuits. To understand the working of microprocessors, microcontrollers, and integrated circuits. To study aircraft digital data systems like ARINC 429, MIL, STD 1553, and fly-by-wire. To learn about electronic flight instrument systems, EFIS, and cockpit displays. To develop troubleshooting skills for avionics systems and instruments. Main topics covered. 1. Digital electronics fundamentals. Binary, octal, and hexadecimal number systems. Boolean algebra and logic gates, and, or, not, NAND, nor, XOR. Combinational and sequential logic circuits. Flip-flops, counters, and registers. Analog to digital, ADC, and digital to analog conversion, DAC. 2. Microprocessors and microcontrollers. Basic architecture and functions. Use of microprocessors in aircraft control systems. Embedded systems in avionics. Programmable logic devices, PLD, FPGAs in aviation electronics. 3. Aircraft digital data buses. ARINC 429, widely used in civil aviation. MIL, STD 1553, used in military aircraft. Fiber optic data buses in modern aircraft. Data transfer, signal integrity, and system redundancy. 4. Electronic instrument systems. Electronic Flight Instrument System, EFIS Primary Flight Display, PFD, and Multifunction Display, MFD. Flight Management System, FMS Integration of Navigation and Performance Data. Air Data Computers, ADC providing altitude, airspeed, and Mach number. Inertial Navigation Systems, INS gyros and accelerometers. Engine Indicating and Crew Alerting System, ICAS, / Electronic Centralized Aircraft Monitor, ECAM. 5. Digital Communication and Navigation Aids. Very High Frequency Omnidirectional Range, VAR. Instrument Landing System, ILS. GPS and Satellite-Based Navigation. Data Communication Systems, ACARS, CPDLC. 6. System Maintenance and Troubleshooting. Built-in Test Equipment, BITE. Fault Detection and Isolation. Software Loading and Configuration Control. Regulatory Compliance in Avionics Maintenance. Importance for AMET students. Develops technical knowledge of avionics and digital electronics. Provides practical understanding of cockpit display systems and digital communication. Prepares students for EASA Part 66B2 avionics modules and licensing exams. Builds skills for diagnosing and maintaining complex digital systems in modern aircraft. Career relevance. Graduates with knowledge in this subject can pursue roles such as Avionics Maintenance Engineers, B2. Avionics System Integration Specialist. Aircraft Electronics Technician. Flight Instrumentation and Display Engineer. R&D roles in avionics and aerospace electronics companies. Conclusion. Digital Techniques / Electronic Instrument Systems is a key subject in the AMET curriculum, bridging digital electronics, avionics, and aircraft instrumentation. It equips future engineers with the essential knowledge to maintain and troubleshoot the advanced electronic systems that make modern aviation safe, efficient, and reliable.